Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm gonna jump back on to close this out, and I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I'm so glad that you're choosing to spend your Wednesday night with me. It's a little rainy where I'm at right now. So it's a great day to sit and do math problems. Like he said, I'm Amy Sink. I'm one of the math specialists here at the Learning Liaisons, and I am an instructional coach here in Central Florida. And the reason why we started late was because I forgot to hit go live. I sat here and did this whole introduction and realized there's nobody sitting here in this room with me. And then I realized I never went live. So that's how my Wednesday's going. I hope you had a great Wednesday. Our intro, like what I like to do usually is ask you where you're from, what test are you prepping for? That helps me guide the conversation tonight. And I always do like an intro question just to get to know you a little bit since we're kind of separated by a computer screen. So in the comment section, let me know where you're from, what test you're prepping for, and do you prefer Halloween, Thanksgiving, or Christmas, or none of the above? I have pumpkins all over my house. They're sitting right here on my table right now. But my favorite is definitely like the winter Christmas season. I love Christmas shopping. I love decorating for Christmas. I love putting, fake snow and trees and everything all over my house. But I definitely right now have pumpkins all over my house. And those came out like September 1st in our house. And Christmas will go up November 1st in our house. So which one do you prefer? And where are you from? And what test are you prepping for? So without further ado, let's get started with our first problem tonight. So, Sarah solved the problem below. Where did Sarah make her error? Where did Sarah make her error? Step 1, step 2, step 3, step 4, or is there no error? Hey, Joseph, good to see you. Thanksgiving and Christmas, both great holidays. All right, so where did she make her error? Hi, Laura, you're from Orlando too. Great, I wonder how far away we are from each other. I'm about 30 minutes north of Orlando. So we have to understand what this is doing. So when I solve an error problem, if I have the time on the exam, I will usually solve it myself and then look for the error. Because so many times when we're looking at error problems, error analysis, it's hard to see someone else's error when we're looking at their work. So I will often myself rewrite the problem, solve it, and then look to see where her work does not match mine. So when I see this right here, I immediately know that we will be using the distributive property. So while this would be more of a middle school, high school question because of the variables that we see, elementary people, you need to understand the concept of commutative property, associative property, and distributive property. So in this case, we will be using the distributive property because we are distributing one factor through the rest. So I'm going to distribute this 8 all the way through and multiply it by everything inside. And I'm going to do the same thing with this 9 right here. I'm going to distribute the negative 9 all the way through. That's where a lot of people make the error. They distribute the 9 all the way through, not the negative 9. So even though we would read this 8 times x plus 3y minus 9 times 2x plus y, what we're really doing is distributing that negative 9 all the way through. Hi, Milagros. You're from Miami. That's awesome. And you're taking the GKT. Fantastic. So when I solve this, 8 times x is just 8x. 8 times 3y, I'm going to do 8 times 3, and the y is going to stay attached. 8 times 3 is 24y. Next, I'm doing negative 9 times 2x is negative 18x. And negative 9 times y is negative 9y. And I'm going to stop. After every step I do, I'm going to stop and kind of see what Sarah did. So I see that she went from step 1, which is the original problem. So she didn't make any errors in step 1 because it's the original problem. So if I wasn't sure about this problem, I could cross off A because it's the original problem. She can't have made any errors because it was the original problem. But step 2, she went from the original problem, which is this. You see they are identical. And she said it's equal to this right here. So I'm going to see, do I have anything close to that? I have 8x plus 24y minus 18x, and then I have a minus 9y, and she has a plus 9y. So what I'm going to do is make sure that I'm correct and I didn't make an error before I assume that it's step 2. When I go back to this section, I know that negative 9 times y is indeed negative 9y. So Sarah made her error in step 2. Then you'll notice, and I'm just going to take us through the rest of the problem so that you understand how they represented this. They just took exactly what she got in step 2 and repeated it in step 3, and then she did her work. And then they combined everything after that, okay? So in this case, step 2 is where Sarah made her error, so that is going to be the correct answer. Now, problem 1B, it's the same problem, the exact same problem, except I ended up actually changing this to be correct. So that is the correct response. But now they're asking us a different question. I wanted to show you that with the same problem, test writers can ask a lot of different questions. So which of the following properties was used to simplify the following expression in step 2? Well, I kind of already addressed this in problem 1, but we'll go over it again. So in step 2, what property did we use? We used the distributive property to get from here to here. We used the distributive property because we distributed the 8 all the way through, and we distributed the negative 9 all the way through. What property did we use in step 3? Let's take this a step further. What property did we use in step 3? In step 3, we used the commutative property. Why? Commutative property. Because we rearranged our addends so that our like terms were together. So I moved the negative 18x here, and I moved the 24y here so that I can simplify easier. Excellent job, Joseph. And then from there, I added like terms together. They didn't ask us that, but I just wanted to throw that question out to you so that we could cover the most bang for our buck with each problem. All right, let's move on to problem 2. Which of the following is equivalent to the number 275? This is definitely a K6 problem. It could even be a pre-K3 problem if I had any pre-K3 people in here. So which of the following is equivalent to the number 275? If you are taking the K6 exam or a pre-K through 3 exam, I need you to know multiple representations of different numbers. So the number 275 is definitely not going to be 2 plus 7 plus 5. If I think about if I have 2 apples plus 7 more apples plus 5 more apples, I'm not going to end up with 275 apples. I'm going to end up with 7, 8, 9, 10, 11, 12, 13, 14 apples. This is going to equal 14, not 275, okay? Don't apologize that you're late. No worries. We all have a life. Here we are hanging out doing some math problems together. Thank you, Joseph, for answering that question. All right, 27 tens and 5 ones. This is where a lot of people get confused because usually we like to look at this problem and we identify it as 2 hundreds, 7 tens, and 5 ones. Or we can write it as 200 plus 70 plus 5. Because 200s is 200, 7 tens is 70, 5 ones is just 5. So these are the most common ways to write the number, but there are not so common ways to write the number as well. So if we're looking at 27 tens, if I counted by 10, 27 times, I'm going to do it super rapidly fast, and I want you to notice something when I do this. This is super important for everybody to understand place value. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That equaled 100, right? 100, 10, 20, 30, 40, 50, 60, 70, 80, 90, 200. 10, 20, 30, 40, 50, 60, 70. That gives me 270. 271, 272, 273, 274, 275. Okay? So, if I look at that, 100 equals how many tens? How many tens did I use to get to 100? 10. 10 tens equals 100. 10 times 10 is 100. So 20 tens is going to be 200, and 27 tens is going to give me 270. 271, 2, 3, 4, 5. So if I have 27 tens, that's going to give me 270 and 5 ones. B. What was option B for the other problem? Closure. And then it was distributive, commutative, and identity. Okay, moving on. 300s minus 35. So if I have 300s, I have the number 300. And if I subtract 35 from that, I can just do long subtraction to figure that out. I get 265. That is not the correct answer either. And 200 plus 7 plus 5, what is 7 plus 5? 12. 200 plus 7 plus 5 is going to equal 212. So that's not the correct answer either. But people will choose A or D very quickly when they're looking at this because they expect the answer to look conventional, like this or like this. They don't expect the answer to be 27 tens. So people will automatically skip that answer because it's unconventional. I promise you, these exam writers often will create unconventional answers just to make sure you understand the concept. So just keep that in mind. Let's move on to problem 3. Oh, I love these kinds of problems. I actually just did one of these kinds of problems with one of my tutoring clients, one of my high schoolers. All right, a pool technician is filling up a pool and is monitoring how many gallons of water are in a swimming pool over a certain period of time. Automatically, I'm thinking of a linear or an exponential equation. Because we are looking at gallons over an amount of time, I'm thinking of a graph. I'm thinking of a graph because a graph has 2 axes. And because I have 2 axes, I can measure 2 different things at the same time. How much water over the amount of time. Moving on. The technician recorded the gallons in the pool on each hour shown. So after 2 hours, how many gallons of water do we have in our pool? 1,100. After 3 hours, 1,650. After 4 hours, 2,200. After 5 hours, and so on. Okay, you get it. Which of the following relates the hours past H and the number of gallons in the pool G? That's a very fancy way of saying which of the following is the equation for this graph. A lot of people will get confused by the verbiage of this question right here. I'm going to read the question again. Which of the following equations relates the hours past H and the number of gallons in the pool G? Do not get overwhelmed by variables, especially odd-looking variables. And do not get overwhelmed by words like equations, relate, things like that. Because I guarantee you, sometimes you will know the answer even though you're getting confused by the language. So let's see what they're asking. They're asking for which of the following equations is true. So if you struggle with figuring this out algebraically, you can just plug in answer choices. So you can just take hours past, plug it in for H, 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 and see if you get this as an answer. Because if I plug in the number 2, I should get G equals 1,100. If I plug in the number 3, I should get G equals 1,650, and so on. So with that said, I am going to plug in the number 4. Why? Because a lot of times, if you plug in the first value on the table, there will be multiple answer choices that will satisfy that equation. But if you start in the middle of the table, you will often eliminate the other answer choices. So I'm going to start with 4. I'm going to plug 4 into H for each of A, B, C, and D. When I plug 4 in here, I get 500 times G plus 100 equals 4. When I subtract 100, I already see that I'm going to get a negative answer. I'm going to get negative 96. And then I have to divide. I'm not going to want a negative number. There can't be negative gallons of water in my pool. So A is automatically out, and I haven't even solved anything. Let's move on to B. 550 times 4. 550 times 4. I'm going to use my calculator. I'm going to use my calculator just to make this a little bit easier. So 550 times 4. What do I get? 2,200. Does that match my table? Yes. So I think B is my answer. But what I am going to do is test one more point, because there cannot be multiple lines going through multiple points. So if I test 2 points in this line and it works, I know it's my line. So I'm going to test 550 times 5. 550 times 5 gives me 2,750, which also matches. So I know that B is my answer. Now, I solved it in a very elementary way for this problem. That is actually not how I would solve it. And my middle school and high school people, this one's for you. So I'm going to switch colors here. I would have solved this very algebraically if this was me. I would not want to plug in answer choices if I have the ability to solve this algebraically. So I know that the equation of a line is y equals mx plus b. So I'm going to look for my b value. So if I see that my change in between each of these is 550, I can quickly see that the change between each of these is 550. And the change between these is a value of 1. If the slope equals y minus y over x minus x, then I'm going to very quickly find a slope value and find a y-intercept value and then choose my answer accordingly. That's, in my head, going to take a shorter amount of time, but not for everybody, which is why I like to show multiple examples. So slope is y minus y over x minus x, which means y minus y is 550 over 1. So my slope is 550. My y value is going to be my g value. Why? Because x is time, which is h, and then y is g. The gallons is dependent upon the time. So my independent variable is going to be my x-axis, and my dependent variable is going to be my y-axis. And because the gallons is depending on the time isn't depending on the gallons, that's how I know that those are my two variables. So this is actually going to be g equals slope h plus b. Now, how do I know what my b value is? Well, my b value is my y-intercept, which is just where x equals 0. So if I take my table backwards and I look at 1 hour past and 0 hours past, then I can figure out what my y-intercept is. What's 1,100 minus 550? 550. And what's 550 minus 550? 0. So I know that my y-intercept is 0, which also makes B the correct answer. However, you can't assume that your y-intercept is 0, because even though the pool technician is filling up the pool could have started with a certain amount of water and they didn't tell us that. So you have to cross-check that with your table. So 2 different ways to solve this problem, both correct. Let's move on to problem 4. Oh, let's move on to problem 3B. Same problem, different question. I've been doing this a lot to you today. I did it with problem 1 too. All right, the pool technician is still filling up a pool and we still have the same graph happening. So I don't need to read all of that. What I am going to read is the question. If the pool the technician is filling up is 10,000 gallons, after how many hours will the pool be completely full? If the pool is 10,000 gallons, how many hours is it going to take to fill that pool completely up? Well, let's go ahead. And this is one of those moments where I like to take my calculator and use the equal button. If you are provided a calculator, I would do 2,750 in my calculator, and then I would add 550 because I know I'm adding 550 gallons every hour. Every hour that hose is putting in 550 gallons. So that's going to equal 3,300. That's number 6. And then if I just keep hitting this equal button, my number is going to just keep adding 550. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do you see what just happened? So now I'm not having to type in plus 550, plus 550, plus 550. I'm just able to tell the calculator, keep repeating that operation. But I noticed something. No answer gave me exactly 10,000. Let me do that again. 3,300 plus 550. That's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. After 17 hours, we have 9,350. After 18 hours, we have 9,900. And after 19 hours, we have 10,450. So my pool became full at what point? At what point did my pool become full? Somewhere between 18 and 19. So what is my answer going to be? Because 18 is really close. 9,900 is way closer to 10,000 than 10,450. So am I going to pick 18 or 19? I'm going to pick 19. Because it's asking after how many hours will the pool be completely full? After 18 hours, is the pool going to be completely full or almost completely full? It's going to be almost completely full. But at the 19th hour, we are going to be completely full. At 10,000 gallons, that pool technician is going to turn that pool water off, but time is still going to tick away. So after 18 hours, we are not completely full, but after 19 hours, we will be completely full. This is one of those crazy rounding questions where we are actually not going to round the normal way that we normally would. However, we are going to look at the situation, okay? So this is another type of problem that they love to give us because we have to interpret the situation. I'm glad that that makes sense, Joseph. Good. All right, now we are looking at problem 3C. Same problem, new question. So, same problem. I'm not going to read the problem. I'm only going to read the question. After 1 hour, how many gallons were in the pool? Now, we already talked about this on this question, how we went backwards to find that y-intercept. So if they gave me hours 2, 3, 4, 5, and 6, then in order to figure out how many gallons were in the pool after 1 hour, rather than adding 550, I'm going to subtract 550 from 1,100, and that gives me 550. So after 1 hour, there is 550 gallons in the pool. We already talked about it, so I didn't want to spend a whole lot of time on this problem, but I just wanted to show you that for one graph, so many questions can be asked. Problem 4. This is good for everybody. Everybody needs to understand how to simplify expressions, use order of operations, all of it. So here we go. Simplify the following problem. 34 minus 10 divided by 2 minus 6 times 4 plus 2 to the third power. All right, I'm immediately going to write PEMDAS at the top of my paper. Why? Because I want to remember that parentheses come first. Exponents, multiplication, division, addition, then subtraction. However, addition and subtraction are partnered. Multiplication and division are partnered. And parentheses and exponents are partnered. So parentheses and exponents kind of are, kind of aren't. But multiplication and division are definitely partnered, and addition and subtraction definitely are. So what does that mean? That means that when I finish my parentheses and exponents and I get to multiplication and division, I can do division or multiplication first. It's not whichever one, it's not always multiplication. It's whatever operation comes first when I read left to right. Same with addition and subtraction. So I'm going to solve my parentheses first, and I'm going to keep everything else the same. So 34 minus 10 is 24. And I'm going to keep everything else the same. I'm literally going to write everything else exactly how it looks. Then I'm going to do my exponents. So I've done parentheses. Now I'm doing exponents. 2 to the third power does not equal 6. 2 to the third power equals 2 times 2 times 2, which equals 2 times 2 is 4, 4 times 2 is 8. 2 to the third power equals 8. Because an exponent tells you how many times you're doing that item that's your base item. So now I'm going to rewrite everything here. And then I'm going to evaluate 2 to the third power, which is 8. So I've done my parentheses, I've done my exponents. Now I'm moving on to the multiplication and division partnership. So when I look at this problem and I read it left to right, I see 24 divided by 2 minus 6 times 4 plus 8. So I'm going to do the 24 divided by 2 first, because even though the M comes first, I'm going to do the division first. Now, in this case, it actually isn't going to affect the outcome of the problem. However, there are many times it does, so we're going to follow order of operations. 24 divided by 2 is 12. Keep everything else the same. And negative 6 times 4 is negative 24. So 12 minus 24 plus 8. Now we are at addition and subtraction. Again, even though addition comes first, I'm going to solve these from left to right. So I'm going to do 12 minus 24, which is negative 12. If you don't understand how I got negative 12 from that, please let me know in the comments and I will explain it. I just don't want to over-explain, but if you don't understand that, let me know in the comments and I will review how I got 12 minus 24 equals negative 12. Plus 8 and negative 12 plus 8 equals negative 4. So negative 4 is our answer. All right. Let's move on to problem 5. And if I see any questions about this problem, I will come back to it. What information can you deduce from the following equations? 2x plus 4y equals negative 24. 6x minus 3y equals negative 12. The lines are parallel and have different y-intercepts. The lines are perpendicular lines with an intersection point at 2, negative 3. The lines are non-perpendicular intersecting lines with an intersection point at 2, negative 3. Or the lines are perpendicular lines with different y-intercepts. All right, so in order to solve this problem, we have to understand some very quick vocabulary. Parallel, y-intercepts, perpendicular, intersection point, non-perpendicular intersecting lines, and I think that's all the vocabulary. So let's do a very fast vocabulary lesson. I'm going to draw a quick coordinate grid here. Here's a line. And here's a line. Those lines, well, I didn't do a very good job, but those lines are parallel because they never intersect. Parallel lines never intersect. Now, perpendicular lines intersect at a 90-degree angle. So if I have a perpendicular line, those are going to intersect at a 90-degree angle. Now, just because two lines look perpendicular does not mean they are perpendicular. They either have to represent the lines with this little 90-degree box right here, or you have to find the slope of both lines and figure that out. I'll go over that in a minute. Intersection point is just where the lines intersect. So this would be the intersection point of these perpendicular lines. But lines can be non-perpendicular intersecting lines. So if I have a line that looks like this and a line that looks like that, those are very obviously non-perpendicular lines, but they still intersect. And so because they intersect, there's my intersection point, but they're just non-perpendicular. And the y-intercept is going to be the point at which that line crosses your y-axis. So this would be the y-intercept of that line, and the y-intercept of this line is going to be like way off the screen. So how do I solve this? I solve this by finding the slopes of these two lines, because I can't figure out if they are parallel or perpendicular if I don't know the slopes. Parallel lines have the same slope. Perpendicular lines have negative reciprocal slopes. What does that mean? That means that if the slope of the first line is A over B, then the slope of perpendicular lines would be negative B over A. So how do I find the slope of these two lines? These are both in standard form. The easiest way to find the slope is going to be to put them in y equals mx plus b form, or solve for y, so that I can find my slope. So I am going to subtract 2x from both sides. So I have 4y equals negative 2x minus 24. And I'm going to divide by 4 on both sides. So y equals negative 1/2 x, because 2 and 4 simplifies to 1/2. And negative 24 divided by 4 is a minus 6. I'm going to do the same thing with this line down here. 6x minus 3y equals negative 12. Subtract 6x from both sides. And I get negative 3y equals negative 6x minus 12. Divide them both by negative 3. And I get y equals negative 6 divided by negative 3 is positive 2. Negative 12 divided by negative 3 is positive 4. Now, this part of the equation doesn't matter right now. I'm just looking at the slopes, which is this value and this value, because that's your m value. Once I figure out what to do with those slopes, I can figure out if they're parallel, perpendicular, or non-perpendicular intersecting. Are they the same? No, so they are not parallel. Are they flipped? Yes. And is one positive and one negative? Yes. So that means they are perpendicular lines. So it's not going to be A because they are not parallel. It's not going to be C because they are not non-perpendicular. They are perpendicular. So now I need to figure out, do they have an intersection point at 2, negative 3, or do they have different y-intercepts? Well, they have different y-intercepts, for sure. This is my y-intercept. So because I know that that's my y-intercept, I don't need to figure out if this point is the intersection point. There's not going to be two right answers unless it says choose multiple answers, select all that apply. So because I see that I have a -6 as a y-intercept and a +4 as a y-intercept, I can automatically say that they have different y-intercepts, which is D. All right, let's move on to problem 6. All right, this is another problem for my K through 6 people or pre-K through 3. When teaching second graders how to regroup when adding two-digit numbers, which of the following teaching strategies should the teacher do first to introduce the concept? Now, just because this problem is written for my K through 6, pre-K through 3, everybody who's taking an exam that has teaching pedagogy on it can benefit from this explanation. So, which of the following should the teacher do when teaching students how to regroup when adding two-digit numbers? We're looking for what to do first. Draw a picture of the two addends and represent how to regroup using a picture. So, for instance, if we were adding 53 plus 26, then letter A is saying that let's draw a picture. 10, 20, 30, 40, 50. Actually, let's do 55 because then we have to actually regroup. 51, 52, 53, 54, 55. And then 26, 1, 2, 3, 4, 5, 6. What they're saying is I can show students how to regroup. I'm going to end up having too many ones. So I can take 10 of these ones and make it a 10. So now I have one left over, and I have 10, 20, 30, 40, 50, 60, 70, 80. I have 8 10s, so my answer is 81. That's a great starting point. Let's keep looking at our answer choices to see if there's a better answer choice. Use an equation to show the two addends and how they can be broken apart to make it easier to add. So, letter B is saying I can do 55 plus 26, and I can break these two numbers apart to make it easier to add. So 50 plus 20 is 70, 5 plus 6 is 11, and 70 plus 11 is 81. That's a very abstract way of explaining how to solve a two-digit number addition problem. So that is definitely not going to be what I do first. Should students understand that? Absolutely. But it's not going to be what I do first. Drawing a picture is going to come before that. Letter C, use base 10 blocks to represent the two addends and then manipulate them to regroup and add. Okay, that is going to come before pictures. When we are thinking about how to teach students any concept, this goes back to where everybody needs to understand this. When we are talking about how to teach any concept, we are looking at doing concrete to pictorial to abstract. So concrete is going to be the manipulatives. Concrete is going to be our manipulatives. Pictorial is going to be what we did in letter A. And abstract is going to be what we did in letter B. So if we are looking at concrete to pictorial to abstract, C is going to be the correct answer. Students have to be given the opportunity to manipulate mathematics in their hands. So They build the number 55. They build the number 26. And they literally take those ones and they group them together and they see that they are the same size as that other 10 block. And then they can exchange it for a 10. By doing all of that concretely, it's establishing a foundation in their brain for them to really understand. Then we can move to a picture representation, and then we can move to an abstract representation. And that process happens with every new concept that we teach. We don't just do manipulatives and concrete on understanding in kindergarten and first grade. We do it with everything that we teach. So our third, fourth, and fifth graders, when we're learning decimals and multiplication and all of that, they're going to get that concrete as well. Thank you so much. I can't see your name. The platform that we're using, it just says Facebook user, but thank you so much. I appreciate that. I'm glad that you're enjoying it. All right, D, let's just talk about D for a minute. Focus on the fluency of facts because it will make it easier to add two-digit numbers if they have their facts memorized. This is an answer choice that a lot of people choose because they assume it's the right answer because it's how you and I learned. As long as you knew what 5 plus 6 and 5 plus 2 and 8 plus 7 was, you were going to be able to solve these problems with no problem at all. Thank you, Tara. But we've talked on Facebook before. I can't see if you're on Facebook, I just can't see your name on this platform for some reason. Yes, D is absolutely abstract. It sounds like it should come first, the memorization of facts, but it actually comes last. Students can't memorize facts if they don't understand the concrete representation of it. So anyways, all that said, D is wrong. All right, moving on to problem number 7. Oh, I love these kinds of problems. Stephen is engineering an open-topped box out of a piece of letter paper, 8.5 by 11 inches. He cuts out 2-inch squares from the corners so he can fold the paper into an open-topped box. What is the volume of this box? So we have an 8.5 by 11 piece of paper, which is just a normal piece of paper. And he had cut out 2-inch squares from all the corners. What does that mean? That means, that comment just made me laugh. That means that these are squares. These are squares. That means it's 2 inches on the top, 2 inches on the side, 2 inches on the bottom, and 2 inches on the side. So that means 2 inches is being cut off here and here, here and here, here and here, and here and here. So if I'm cutting out 2 inches from all of those sides, then that means when I fold this piece of paper up, that's gone. Those little corner pieces are gone. So this side of my box is no longer 8.5. What is that side now? It's going to be 8.5 minus 2 minus 2 because I have to subtract this 2 and I have to subtract this 2. So 8.5 minus 2 is going to be 4.5, okay? So this side is 4.5, which means that this side is 4.5. Now I'm going to do the same thing with the bottom. 11 minus 2 is going to give me 7. So this side is going to be 7. Now, when I create my box and I find the volume of it, I have a side that's 7. I have a side that's 4.5. And how tall is my box? My box is 2 inches high because when I fold those corners up, this becomes my height. How do I find volume? Length times width times height. 7 times 2 times 4.5. So 7 times 2 is 14 times 4.5 gives me 63. Where most people make their mistake on this kind of problem is they forget about the 2 on top and the 2 on the bottom. They only will subtract one of the 2s. All right, we are running out of time. Next week, we're going to start with the surface area of that same box, and then we'll finish the problems we didn't get to. I also have another fun one for my middle school and high school people, this one. So we'll solve this one next week as well. Rebecca, you know what? My husband says the same thing about this. He doesn't understand how I enjoy any of this, and that's okay. We all have different things that we love. So I'm going to turn it back over to Dr. A. I hope to see you guys next week, and I hope that you have a great rest of your week. I'm going to turn it back over to Dr. A now.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.